Today we're going to be looking at factoring a difference of squares. Now remember, in math the word difference means we are subtracting, so just a very quick way to see what a difference of squares would be. A square is when you have something squared, so this is a difference of squares. So that is a difference of squares. However, if you have addition, then this is not a difference of squares. This is a sum of squares. So that's important because sometimes students will see two squares and they will factor it like we have a difference of squares. But if they're being added, then that's not a difference. That's a sum. Okay, so let's look at the rule. When we have a difference of squares, the way we factor it is we're going to get two brackets. You take the square root of the first term. So my first term is a squared. When I take the square root, I will get a and a. And then you put a plus and a minus. It doesn't matter what order you put them in. You could put the minus bracket first. And then you take the square root of the second term. So my second term here is b squared. So when you take the square root, you will get b. So essentially you have a plus b, a minus b. Like I said, this could also be written where we take the square roots of the first term, and then instead of going plus minus, we can go minus plus, and then the square root of the second term. So those are, it's the exact same thing, because remember, when we multiply, the order of the brackets that we're multiplying doesn't matter. Okay, so I can have the plus bracket first, or I can have the minus bracket first. All right, so let's look at some examples. The first one we're going to look at, n squared minus 49. So here we're going to have two brackets, and then we're going to take the square root of the first term. So the first term is n squared. When I take that square root, I will get n. And then we can go plus minus or minus plus, doesn't matter. And then we're going to take the square root of my second term. So our second term is 49. So the square root of 49 is 7. And let's go to another example. Now here, again, I do have perfect squares. 144 is a perfect square, and then 25n squared is also a perfect square. So we can go straight to our brackets. The square root of my first term is 12. And then I will have plus minus. And then the square root of my second term is 5n. Students sometimes get confused and they think that we need to have the variable portion come first, and that's not how it works. It's the first term in my difference of squares is the first term in all the brackets. It doesn't matter whether the variable is the first term or not, okay? Okay, now this one might look a little bit different because now you're looking at powers that are greater than 2. So we have to remember, what does it mean to take a square root? A square root halves the power. So if your power is divisible by 2, then you have a perfect square. So that's an important little note to have. So let's just write that down here. So if the power is divisible by 2, or an easier way to say that is if the power is even, then you have a perfect square. So that's an important thing to remember. So here, we're going to get our 2 brackets, and then the first term is a to the power 6. So the square root, remember square root divides the powers. This becomes a to the power 3. And then I will have plus minus, and then I will have b to the power 2. So let's look at this one. And I want you to remember, when we started factoring, something we learned was to factor out an HCF. And whenever you are factoring, you always look for HCF first. Before you try to identify a special case, like in this case, a difference of squares, you will always look for the HCF first. And that is very important. So a little note is always look for the common factor. So look for the HCF. And we pull that out first. So here, our HCF is actually A. So when I pull out that A, now inside my bracket, I will have 81 A squared minus 49 B squared. Now I can identify that I have a special case, which is a difference of squares, so we have to go one step further. So the A still stays there as my HCF. You can't take it away. And now the difference of squares factored into 2 brackets. My first term is 81A squared, so that square root is 9A, so I put that over there. And then my second term, well, first I'm going to put my plus and minus, and my second term is 49B squared, and so that square root is 7B, and that is how we would factor that one. That's completely factored now. Now we're going to look at something a little bit different. It's still a difference of squares, except instead of having a single term squared, we have a bracket that is being squared. Okay, but the approach is still the same. I still have something squared. Now just my something happens to be a bracket. So I have something squared minus something squared. So this is a difference of squares. And the first term is this. And so the square root of that is just the bracket by itself. So those are my 2 brackets, and I'm going to put that first term in to both brackets. And we attach a plus and a minus. And now we take the second term, which is just y. We're not done here. Because unlike the other examples, I'm just going to scroll up to show you our other examples. If you look at all these examples, my brackets could not simplify, meaning n plus 7 does not add because n and 7 are not unlike terms. N and 7 do not subtract. 12 plus 5n cannot be combined. 12 minus 5n cannot be combined. So in all of these scenarios, we had our brackets that had unlike terms, so we could not simplify them. However, now I actually have like terms. I have y with y and y with y. So those are like terms. And so I can actually simplify my brackets. This becomes 2x plus 2y. And then over here, I have just 2x because y minus y is 0. And we actually get one more way to factor. So whenever we give factoring questions, sometimes you'll see where it says factorize fully. And that's what it means. This is what they're talking about, is where you get to go even further. Because over here, I now have a common factor of 2. So I want to pull out that common factor because this bracket now is not factored because there's a common factor in there. So I will need to pull out that 2. And when I do that, inside this bracket, I'm left with x plus y. And then I have my second bracket, which says 2x. Okay, now that is completely factored. We could simplify or just rearrange this to make it look a little neater. And what we do to do that is we're going to combine this 2 and that 2x so that we actually will have 4x because 2 times 2 is 4, and then we have x plus y. So you can see how this very simple expression took a few steps to get to a final answer. Now, generally, we would just, this line would be accepted, okay? But I want you to be able to see how we can get to the final to make it even look even better, okay? So even more neat and concise would look like this here, okay? However, this line would not get you full marks because we haven't factored fully, simply because we ended up with a bracket that had a common factor in it. So we had to take out that common factor. And as a final example, I want us to look at this one. So we can see that n has an even power, so we know that we can factor that as a difference of squares. So we're going to get 2 brackets. And our first term, which is n to the power 8, so when we take the square root, we just divide the powers. So that becomes n to the power 4. And we have n to the power 4. We are going to say plus and minus. And then we're going to take our second term, which is 81. And that becomes 9 and 9. Again, in this one, we're not done because this bracket is a sum of squares. So we can't do anything with it. But this one, that's a perfect square, that's a perfect square, and that is subtraction, which means this bracket is a difference of squares. So what ends up happening is the first bracket has to stay the same because remember it was a sum. However, now my second bracket is going to split again. And we take the square root of the first term, which becomes n squared. We have a plus and a minus. And then we take the square root of the last term, which is 3 and 3. Now we cannot go further because this is a sum and this is a sum, so they can't happen. This is a perfect square, however, and we have a difference. However, 3 is not a perfect square. So now this bracket will not split. And so this question here has taken us one step further, and that's important to look at. Whenever you are factoring, you want to make sure that you have factored fully. So when you get to the final answer, you are left with nothing else can factor. Okay? And that is factoring a difference of squares.